Thanks. Well, I'm really glad that I'm presenting on this stuff with Claire and Jess today because this is something that's very near and dear to my heart. So I'm excited to get into it. So I'll be also talking about cross-project comparisons and databases. And to kick us off, Miller Hull also has an embodied carbon commitment that's been released in this past year. We are looking to close the gap of greenhouse gas emissions and drive high-performance building strategies forward through design, education, and advocacy. And so what I'm going to be talking about today, kind of the tally workflow, standardizing results, falls firmly into the design piece of the bucket. So again, some touchstones on where we're starting. So right now we have 52 projects in our database, a few of which have a few versions run. So it's the same project, but it's just been run through Tally multiple times. The tools that we use to get there are also Tally and Tableau Prep and Desktop, which I'll be demonstrating a little bit today. A typical study scope for us is so the product stages, A1 through A4, I just want to point out that we don't include A5 data, which is the impacts of constructing a building on site. That's something that we're not currently tracking. We always include biogenic carbon, which is a decision that we took after doing some research on forestry and biogenic carbon in general. The typical reference lifespan for our studies is 60 years in alignment with LEED, although sometimes this will be adjusted based on the certification that a project is pursuing or the particular interest of the client. And last but not least, the material study scope. We always include substructure, superstructure, and envelope, and interiors is a little tricky. We almost always have it, but occasionally we will exclude it for projects that are core and shell projects only, where the TI elements are the responsibility of the tenant. In terms of the types of projects that we have in the database, it's a very diverse database. We have all 5 Miller Hull market sectors represented. So we're talking from cabins that are in our live market sector to border crossing infrastructure that's over in our serve sector. And in total, there are 14 people who have run at least one tally analysis in the office, with one data analyst who's kind of wrangling it all together, and we're looking to upskill people in the future as well. And last but not least, internal user guide. Yes, we have one, but it's also in progress. And I'm really glad that Jess brought up hers because I'm already getting great inspiration for how to move ours forward. I'll start kind of from backwards and go to the front here. So the user guide. We basically have some technical documentation that's available to everybody at the office, like as a wiki page that goes through a step-by-step of setting up a tally model and then highlights a few of the common pitfalls. So for example, we'll tell people, make sure to use your working Revit model because we won't be able to transfer your definitions. If you're just starting out a Revit model, then make sure that your work sets and phases are really distinct because that's what you're going to be using to set the scope of your tally study in the future. Something that we found is, if there's a linked model from a different discipline coming in, then we want to make sure that we make a copy on our server so that we can actually go into the linked model and make the tally definitions inside that model. And last but not least, this is probably the fastest way of dealing with the consistency issues that Claire and Jess have brought up. But basically, right now we're saying that it is the responsibility of the modeler to make sure that Revit material names, the descriptions, and the thicknesses and assemblies match. That's a very blanket statement because there are a million ways for this to go wrong, but that's how we're doing it right now. The piece that I wanted to mention is the goal and assessment scope box in every tally report, which is, in my opinion, a hugely underutilized resource. So every tally report, there's a little box to type in what the study is about. And if we use it consistently, then we get a ton of better information about the study that can be used, 4 years or 4 months down the line when we open it back up again and try to figure out what the heck we did. So right now we're asking folks to always include a description of the study scope, a description of the major emissions. So if you're not able to define the mullions for some reason, I want to know. Maybe it's not significant, maybe it is, but at least we'll be able to address it in the future. Study purpose, are we doing this in CDs for documentation for certification, or is this a design option study? And last but not least is the version, because we really want to get to a place where we are running tally multiple times throughout a design process and not treating the results as a precious, it's all done kind of thing. So to that end, this is kind of boring but really important, is to have a consistent naming structure for your tally studies. This is something that's been really helpful for me in doing kind of data analysis after we get so much information in. We want to make sure that we're capturing the date of the date of the study, the phase that the project was in at the time. So as Jess was mentioning, sometimes when our models are earlier phases, our material scopes will be greatly reduced, and that will affect the overall GWP result at the end. A version number and a study type. And before I stop harping on versions, I wanted to show that the reason why it matters is because it also allows you to track the progress through your tally modeling process. So sometimes there will be changes in the Revit model that will affect the global warming potential result of a tally study. So this is something that could be a design change. We've decided to go with a thinner roof assembly, which means less purlins. Let's run the tally model again and see what that did. But there's also tally changes that you could make. So like we've decided to swap in a steel sheet definition instead of the carbon steel sheet definition and see what that does. So discrete versioning allows you to actually track the impacts of those changes and make reasonable conclusions out of that information, right? So was it your design change that really changed everything, or is it the way that we're treating the data that could change the results? So why do we build a database? I think that there's basically two reasons to get into it. The first one is to pull out the most actionable pieces of information from a tally study so that we can move on and actually achieve some embodied carbon reductions. And the second piece is enabling cross-project comparisons in one environment. And the way that we started doing this was 2 years ago with Bree McCarthy, who's on the call right now, who put together this kind of InDesign template of what could we get at from a tally study in one page. We could basically get some stuff about the study description, look at comparing our results to other studies, analyzing where the impact allocates, identifying some of the material hotspots, and then that last bar is kind of aiding result interpretation for project teams who may not know what 500 kilogram CO2 equivalent looks like, and honestly, I don't either. So we decided to take this template and then automate it and run through it. So that's where the tools that we're currently using come in. I use Tableau Prep and Tableau Desktop for these reasons. Tableau Prep is a tool that lets us to clean the data that we get from a lot of different tally runs. For example, in earlier versions, the life cycle stage transportation was labeled transportation, but now it's called A4 transportation. But we want to make sure that those records are treated in the same way. It also allows us to combine data from multiple Excel files. So when I'm talking about 52 projects, that's 52 Excel files that need to be combined consistently together, which is pretty easy with this tool. And it can also be used to systematically append data. So things that Tally doesn't necessarily collect. Tally doesn't know which market sector the project belongs to. Tally doesn't know the construction type of the project. But this information is usually kept somewhere else. Like there could be an internal database that your firm is already using that collects that information. Tableau Prep allows you to kind of splice that data in and append it to your analysis and run with it. And the second piece is Tableau Desktop, which is for visualizing data. And at this point, I'll do like a little demo of what it actually looks like. So this is a Tableau Prep environment. It looks like a flow of data. There are a lot of Excel files that are connected to it over on the right. On the left. So each one of these records represents one Excel file. And if I click into it, you'll see that in that Excel file, there are a bunch of sheets. And I've connected some of these sheets to my database and gone through a series of repeatable steps to combine them. So for example, right here, what's being shown is that for this project, these 3 Excel sheets are being queried and then combined into one table. Then there's kind of a cleaning step to make sure that we're extracting the information that we want, such as who was the modeler, what was the date that the study was run, what was the version of Tally, whatever. And once all of that information is kind of all together for one project, I can join it together and say, hey, all of this belongs to this project. But now let's combine projects together. So we'll have all of our sustainable infrastructure projects combined and tagged as sustainable infrastructure projects. All of our serve market sector projects, again, combined. So it's kind of like braiding all of the data together and adding a little bit of information along the way. But the whole point of doing this, without getting too nerdy and running out of time, is that, you know, you get your tally results and they look like this. There's a bunch of pivot tables on different sheets. But really what you want to get to is something like this that combines all of the information into one really ugly, really big database file that has it all in one place and allows you to slice and dice the information however you like. Which gets me to kind of the second part of this, which is the slicing and dicing of data. So what it allows us to do is to recreate that dashboard, but automate what's going on. So I've set up this dashboard to always show us what divisions are the most impactful, which materials are the most impactful, and how the impact allocates across these three characteristics. And the great part of doing it this way is that, you know, we can go in and go to any project that has run tally, which collects information in the same in the same format, and then repeat the same data visualization process. So I'll always get the same type of visuals for the project team to review. It also helps with QA because then I know what's weird. So if I see a project or a material that I've never seen make it to the top 5, then that's probably something I'll flag and review. And it allows us to look at projects altogether. So this is the 52 projects that I mentioned, aggregated by their different market sectors, looking at their total global warming potential and then global warming potential per unit area, which is really what we're interested in when we're trying to set benchmarks. And it allows us to build better benchmarks so that, you know, I can tell you that right now, based on the data that's in our portfolio, our mean global warming potential per unit area is 545 kilograms of CO2 equivalent per meter squared. But maybe if I'm trying to set a benchmark for the next civic building, I could instead look at these 4 civic projects where that benchmark mean is significantly lower at 351. And last but not least, there's the allocation dashboard, which looks at where does the global warming potential allocate by life cycle stage, division, or Revit category. And basically it's another kind of QA tool where I can go in and say like, hey, is it really weird that this particular project doesn't have that much impact happening in the product stage? Why is that? Is that because it's a TI? Is that because of a scope issue? Whatever. And allows us to draw some big conclusions about things like, man, we really should be paying attention to our floor structure and wall Revit categories, because for the most part, that's going to make up like 80% of our impact. So not too worried next time that curtain wall mullions aren't exactly perfectly defined, because it's not significant. So yeah, I think that's a really fast crash course on what's happening with Tableau, but there are things that aren't working. The things that aren't working are quality assurance. This is how do I control the data quality when different users are inputting data into Tally, and hopefully I'll use the lessons learned from Claire and Jess today to make it better next time. The next thing that's not quite there yet is a true splice with the internal database. Like, we know that we're collecting so much other information about our projects, like what is their energy performance, how are the soil conditions, what is the building code that the building is built under. All of this information could be used to make the analysis better. It's just not done yet. And renovation and biogenic carbon, which is like a whole other thing. Like, it's really difficult to control for quality in these cases. And this is my laundry list of frustrations with data that will always exist, but the truth is we're all doing our best. Like, the EPDs aren't perfect, but the best thing to do is just to keep doing it. And the things that are working, so the database helps us have a faster QA process. Since I'm always looking at the same graphics and so are the project teams, we're all used to looking for scanning for the top 5 materials, figuring out whether that's a mass thing or if that's a material type thing. It also helps us have better conversations with design teams, and these little blue snippets are like things that I've actually said to design teams. Thanks to this process, you can go in and say like, hey, about those partition walls, is there anything that we can do about them? Is there any chance that we can replace them at this stage or reduce their mass? The second thing is the large scale conclusions. One direct impact is, I think a lot of people have heard about food miles and are concerned about the transportation of materials to site. But thanks to a database, you can look at the overall aggregate view and say like, hey, let's not focus there actually. Like, we've consistently seen that this contributes less than 5% to the overall embodied carbon impact. So let's focus on product and manufacturing of the materials that we specify. And the last piece is it helps us to contextualize our results. That's so, so important because it's impossible to tell what 500 kilograms of CO2 equivalent actually means unless you have a database to relate it to. And this was a pretty cool finding was, this was case where for building A, they achieved a 7% reduction in overall global warming potential through supplementary cementitious materials into their concrete mix, which is like, I was like, oh, that's so cool. But the project team doesn't necessarily understand the gravity of what that means unless you contextualize it and realize that all of that 7% is actually equivalent to the entire life cycle impact for another building that they already know and they have designed. Like, hopefully that leaves a mark.